Good morning to one and all. I'm G. Vamshi from branch of Triplet. Subject was CAPD. Today's my topic was about random variables and probability distribution. A random variable is a numerical description of outcome of statistical experiment. A random variable that may assume only finite number or infinite sequence of values is said to be discrete. One that may assume any value in some interval on the real number line is said to be continuous. For instance, a random variable representing the number of automobiles sold at a particular dealership on one day would be discrete, while random variables representing the weight of person in kilograms or pounds would be continuous. The probability distribution for random variables describes how the probabilities are distributed over the values of random variables. For a discrete random variable x, the probability distribution is defined by a probability mass function denoted by f of x. This function provides the probability for each value of random variable. In the development of probability function for discrete random variable, two conditions must be satisfied. One, f of x must be non-negative for each value of random variable, and second, the sum of probabilities of each value the random variables must be equal 1. A continuous random variable may assume any value in interval on real number line in a collection of intervals. Since there is a finite number of values in any interval, it is not meaningful to talk about probability that the random variables will take on specific value. Instead, the probability that continuous random variable will lie with a given interval considerable. In the continuous case, the counterpart of probability mass function is probability density function, also denoted by f of x. For a continuous random variable, the probability density function provides the height or value of function at any particular value of x. It does not directly give the probability of random variable taking on specific value. However, the area under the graph of f of x corresponding to some interval obtained by computing the interval of f of x over interval provides the probability that variable will take on value within the interval. The probability density function must satisfy two requirements. One, f of x must be non-negative for each of random variable, and second, integral over all values of the random variable must be equal to 1. The expected value or mean of a random variable denoted by E of x or nu is weighted average of the values of random variables may assume. In the discrete case of weights are given by the probability mass function, and in the continuous case of weights are given by the probability density function. The formulas for computing the expected values of discrete and continuous random variables given by equation 2 and 3 respectively. E of x equal to sigma x of f of x, E of x equal to integration x of f of x dx. 3. The variance of random variables denoted by var x are sigma square weighted average of the square deviations from the mean. In the discrete case of weights are given by the probability mass function, and in the continuous case of weights are given by probability density functions. The formulas for computing variance of discrete continuous variable are given equation 4 and 5 respectively. The standard deviation denoted by in positive square root of the variance. Since the standard deviation is measured in some the units as random variables and variance measured in square units, the standard deviation often the preferred measure. First, binomial distribution. Two of the most widely used discrete probability distribution are binomial or Poisson. The binomial probability mass function equation 6 provides the probability of x successful occurs in n trials of binomial experiment. F of x equal to n by x into p of x p power x into 1 minus p power n minus x. And this PPT made by G. Vamshi.